Yes, sir. I warmly welcome you all again to Second International Conference on Sustainable Construction Technologies and Advancements in Civil Engineering, organized by Department of Civil Engineering to Vishnu Engineering College for Women, Bhimvaram, in collaboration with Indian Concrete Institute Student Chapter. Now, let us have a keynote talk on innovative concrete material modification for sustainable civil infrastructure applications by our eminent speaker, Professor Chen. Professor Chen obtained his bachelor's degree in 1989 and a master's in geotechnical engineering from West Virginia University in the year 1992. He completed his PhD in structural engineering from West Virginia University in 1996. Professor Chen worked as a faculty in the University of Alabama at Birmingham and is currently working as a professor in the Department of Civil and Environmental Engineering at UNC Charlotte. He is a recipient of the 2007 TechWeb Visiting Professor at NIT Trichy and was honored with Fulbright Nehru Academic and Professor Excellence Award at NIT Trichy in 2014. He also served as an international faculty for the Indian National Global Initiative of Academic Networks sponsored by the Ministry of Human Resource Development, Government of India in 2019. Also, Professor Chen was operated as the chief of the ASCE reconnaissance team and led to the Philippines for post-Super Typhoon Haiyan assessment. He also worked as a project head of a National Science Foundation project in assessing the impacts of Hurricane Maria on the power grid in Puerto Rico. Professor Chen is specialized in laser-based and non-contact sensing techniques, and his research projects are funded by the U.S. Department of Energy, the U.S. Army, the U.S. Department of Transportation, NSF, EPRI, Power Industries, and local DOTS. He is an active member of ASCE Forensic Engineer Division and is former chair of the Committee on Forensic Investigation. His research interests are in the areas of power transmission structure, carbon storage in geological formation, remote sensing for bridge monitoring, forensic investigation, and condition monitoring, especially after hurricane disasters. Professor Chen blazoned copious publications and is a well-renowned speaker in several programs and institutions. Thank you, sir, for this concurrence with ScTACE 2021. And now I request Professor Chen to take over the session, sir.
Will I be able to share my screen? Can you see my screen?
Yeah, now it is, we are able to see. Yes, sir.
Okay, thank you. Because of the internet connectivity, I will try to speak slowly. But thank you for the introduction. And I'm going to discuss about some innovations in concrete material for energy infrastructure application. My inspiration for this conversation is really based upon my background in hurricane investigation, especially pertaining to some of the things that we've seen during the past 30 years on climate change, and also related to energy infrastructure responses. And so I will be talking about what are the concrete technology that we can apply to the energy sector. I will show 4 different applications, and then I'll conclude my presentation. Climate change, one of the key results of climate change is the extreme storm events, okay, what we call the superstorms. This is due to higher sea surface temperature and rising sea levels. As a result, there is an increase of the amount of water vapor in the air, which indicates that it will need more energy to move this amount of water vapor. And as a result, there will be bigger storms, which with wider storm areas, higher intensities, and stronger storm surge, such as flooding of the coastal areas and wave actions. And this kind of results would directly impact on the structural design for all coastal and inland structures. And we have seen many of those examples. And this is just to show you the significance of the sea level rising and the sea surface temperature anomaly and the amount of critical storms that has been promoted since the 1900s. In the US, we have across the entire continent, we have investigated several areas where we have seen a predictable increase in high category hurricanes, especially categories 3, 4, and 5. And Maria, which will happen in 2018, is one of the most significant storm effect that happened in the US. The tropical storm that made landing in Puerto Rico, the island was 185 miles per hour wind. And at such a high wind speed, the island was not prepared. So entire island has lost its power level. And what we have observed is there are a lot of critical energy infrastructure collapse, including substations, wind turbines, as well as different transmission structures. And here are several pole-shaped structural failures. And as a result, as I mentioned, almost the entire island has lost power. And this is the before and after satellite image of the night light in Puerto Rico before and after Maria. And you can see the devastation impact on the island more than a year before the entire island has its power returned. And so this creates a huge issue, and many people have died in this event. Here we have written about 3,000 people died, but the official count is more than that. And one of the critical issues is, of course, the power transmission infrastructure. So here we have some picture, and these are pictures taken by the local power authority who will share the data with us that shows significant truss structure, which is the predominant high voltage power transmission type that has damaged due to the wind force. Another inspiration for this study is really the use of concrete technology. So concrete is the most widely used construction material in the world. However, many of those concrete are aging, especially for the energy infrastructure. And so there is a new question about how we can improve on the concrete technology so that we can enhance the performance of those aging infrastructure. This shows you the reactors, nuclear reactors used in the US and their relative age. And this is a little older data. This was published in 2010. So all this age will have to push 10 years behind. Again, it's an indication of the aging infrastructure. So we are asking the question, what can we do to improve the climate using concrete? Now, concrete technology historically only applied to the use of building structures. Okay, so even we have high strength concrete, we have concrete with waste materials. The key is still focus on the building science. In this talk, we want to look at a totally different way of using concrete. So here I'm going to give you 4 examples. First one is, can we use concrete for thermal energy storage? Okay, so when we have a storage capacity, then we are able to use renewable energy. Okay, so that would be one way to help the climate by transitioning from fossil energy use to using renewable, which is not storable at this point. And the second technique that I'm going to present is, can we use concrete to absorb CO2 so that we can actively reduce the amount of carbon dioxide in the air, which would be helpful to greenhouse gas problem. And then the next one is, can we modify concrete so that we can enhance wireless power transfer, which would help to promote electric vehicles? Okay, so electric vehicles runs on batteries and they don't have emission problem, which is one of the best. They may still dependent on fossil energy through the energy production. However, we can remove the emission problem away from urban scenario, and hopefully that would help with, again, climate issue. And lastly is to develop self-sensing concrete, which will make concrete more efficient as both building technology as well as energy storage technology. So those are the 4 examples I will present. Okay, and these are the benefits that we see from those techniques. Okay, here are the example for thermal concrete. It improves energy use, it reduces energy loss, and it reduces greenhouse gas. CO2 concrete, which is the carbon concrete that I will present, it strengthens concrete. So carbonated concrete is actually stronger than regular concrete. And further, it would encourage electric vehicles and reduce reliance on fossil. And the third one is magnetic concrete, which, again, as I mentioned, it reduces emission problems and it makes concrete smarter for energy use. Okay, and it reduces the aging infrastructure. So the first technology we'll present is the thermal concrete for energy storage. So mass concrete has a lot of material that if we can heat it up, and then that way would store the energy. And here is a typical application where hot water, water is being used to store, to transfer heat from building applications to those concrete mass. And so this is a technology that is growing in application. And in our laboratory, we wanted to demonstrate how this works. So we built concrete cylinders and then allow hot water to go through them so that we can determine how much is the temperature or the energy can be stored, heat energy can be stored in those cylinders. And this is the casting of those concrete cylinders. And using finite element, we can simulate the thermal process. So this is a comparison between we use infrared camera and versus finite element modeling. So using finite element modeling, we were able to quantify, and when they match the real life scenario on how fast can we store energy as well as how long they can be stored. We also use monitoring technique such as using thermocouples and electrodes, which makes the concrete self-sense. Okay, so I will talk about self-sensing at the end of the lecture, but this is where we are demonstrating this technology. Here is the concrete specimen that we put several sensors on them, and then you can see when hot water goes through the cylinders, it heats up the material, and then we typically do the test by stopping the water flow so that the material can have its natural cooling down, so that we can quantify the conductivity of heat through the process. And this shows you the result of finite element and actual temperature increase during the heat out process. So you can see that they match very well. So using this is an inverse method of determining the heat conductivity of the concrete material. And this is a voltage. So we are using electrodes to measure the voltage drop during temperature cool down. And you can see that there is almost linear correlation between the cool down process, which can help us to develop correlations that can be used for the design of such technology. To understand further about how concrete material reacts to thermal effect, which is a multi-physical phenomenon. So we use the electric self-sensing technique and the thermal measurement method on concrete specimens, which are built in the beam shape. And this is finite element and infrared imaging of the same specimen. So we can see there is a direct correlation between the theoretical model and the actual experiment. And again, we demonstrate that both voltage and current can be correlated to the temperature change. And because voltage and current are the two sides of the equation, okay, which directly relates to the resistivity of the material, so we can also measure the resistivity as a function of the thermal property for those kind of concrete. And the next application is CO2 storage through mineral carbonation. So mineral carbonation is a natural weathering process of rock, okay, especially rock with a high content of magnesium, iron, and calcium, okay. And in literatures, we have seen people propose to use olivine and serpentine as the potential feedstock for mineral carbonation so that we can reduce the greenhouse gas in the atmosphere. And the typical measure is if you have 2 tons of silica mineral, then you can capture 1 ton of CO2. Okay, and there are other industrial processes resulting in alkaline-based waste, which are also valuable materials for feedstock for mineral carbonation. Okay, and then there are other waste materials such as the incineration outputs, especially slags and the cement productions are potential feedstocks. And so we have imagined if we can mix, if we can use cement to increase the carbonation, then we can make concrete into a natural absorbing CO2 material so that it will clean up the air naturally. Okay, and this shows one of the techniques to increase the surface area for absorption is by making porous concrete. And so we actually, to study such a thing, we have to come up with our own carbon absorption test device. Okay, so this is a schematic drawing of what we call the CTF PRC test chamber for absorption test. And the goal is to quantify how much CO2 can we absorb in different cement mix design. And this is the actual device that we fabricated in our laboratory, which shows you a very high pressure chamber that we can apply high pressure CO2 into the chamber. And by monitoring the pressure drop, we can actually quantify the amount of volumetric loss of CO2 in the material mix. And this is the outcome. This is the microscopic image of the carbonated concrete showing the actual carbonates that are being formed. And so this is the physical evidence that carbon concrete is able to absorb CO2 and permanently remove them from the air. And through experiments, we can see that within the first few seconds, significant amount of CO2, first few hours, you can see significant amount of CO2 are being absorbed quickly. We quantify that because concrete continued to age for 28 days, but within the first 2 days, over 15% of the CO2 that would be per volume of the material can be absorbed within the first 2 days. And this is a significant result because it shows active absorption. And we can also further differentiate between physical absorption and chemical absorption. So chemical absorption happens when the material is still wet and the chemical reactions result in the carbonation of calcium material producing calcium carbonates. And physical absorption is due to the porous volume. And so pressurization would force CO2 to further go into the pores of the material and result in the absorption process. What is the application? It's everywhere. It's concrete roads, concrete buildings, anywhere that you can imagine the use of concrete, you can imagine carbon absorption. So this is a really, really cool technology. And we are hoping that the world will catch on the study of carbon concrete so that we can actively reduce CO2 in the world. The next technology we want to show the use of concrete for climate improvement is to use magnetic concrete for wireless power transfer. Here's a picture showing that we are developing wireless power transfer electric trains. And so this is one area of our focus, but the wireless power charging is a technology that is quickly being adopted by the electric vehicle, EV domain. And electric vehicles are zero emission technology based on lithium ion batteries. And so all you have to do is to charge them overnight so that you will have power to be mobilized. And wireless power charging is a cool technology because it can help reduce the actual plug-in into the system, and also it can be made dynamic so you can charge a car while it's driving. Okay, and it's based on a very simple principle that was developed originally by Tesla of wireless power charging. So this is based upon the principle of electromagnetic field generated by two different magnetic coils. And through the interaction of the two, there is a conversion of magnetic field and the induced magnetic field on the receiver side, which can transfer the electromagnetic field into electricity through the power electronics. And so this coupling system makes a very efficient energy transfer technique. Okay, and as I mentioned, this is great for EV because you can imagine cars just parked on top of the wire. As long as the car itself has the wireless receiver on its end, then the car can be charged for however long time. This is our laboratory train. So we actually have a train in our lab. It's a rideable park gauge train as seen on the top picture here. So we are developing technique that would make this train wireless power transfer. And we have several designs. This is seen as the two coil system that can transfer electricity to this electric locomotive. And we are also developing techniques so that we can charge them dynamically. So here you see 4 transmitters and 1 receiver. So the receiver is put on top of the locomotive. And so using 4 receivers, we can move the train and transfer electricity at the same time. And then next we're going to do is to increase the efficiency of the power transfer by making the coil placed on concrete core material. And we make the concrete core material magnetized by putting steel fibers in the concrete. And so this is a ferrite. Ferrite is a very efficient magnetic permeable material that is commonly used for wireless power transfer as the core material to support the least wire coil. And ferrite material has 3,000 permeability. So in our system, we were able to receive a 9.1% of energy transfer efficiency at 4 watt of power transfer at 6 volt input. And we use our own
Sir, hello. Sir, we are unable to hear you, sir. Please unmute, sir. Please unmute, sir. It went to mute.
Oh, okay.
All right.
Yes. Okay. Sorry about that. Finally, the last technology that I wanted to demonstrate is the self-sensing concrete. Self-sensing concrete is based upon the theoretical basis of multi-physical correlations between the stressing of concrete based up and the increase in the material conductivity when material is being stressed. And this shows you, but it is a very complex problem. Why? Concrete material, because concrete material is very complex. Okay, this picture shows you that there are a lot of micro cracks in concrete, and we add the steel fibers in the material, which are in different shapes. So they result in different magnetic field and result in many phenomena of the added current transmission. Okay, so while on one hand, it improves on the conductivity, on the other hand, it actually induces variabilities in the electric current flow. But nonetheless, in our experimental work, so this shows you the mixing of steel fibers with concrete into our material. And to be able to sense the electric current, we embed copper wires in the concrete beam element. And using cylinders, we first start with cylinders. We show that there is a reduction of resistivity when the concrete materials are being compressed. So showing that there is a direct correlation. And then it is also a function of the maturity of the concrete material. So again, we demonstrate the viability of such technique. And then we start testing using load test on a concrete beam or column in this case, where you can see that the electric current is being induced into the material. And then when the load is compressed, we can correlate the voltage drop versus the change in the current. Here's again the picture of the samples that is being built, and here's the load test set up. And you can see that we have both strain gauge as well as voltage measurements across the specimen. And this is really the neat picture. So we do loading and unloading cycles, and you can see the strain gauge and the resistivity the voltage measurements are compatible, and which shows us that there is a linearity in the voltage drop versus the stress strain relationship of the material. And so this shows you the stress strain curve. And based on that, we are able to make correlations between the electric resistivity, which has to be derived, versus the strain of the material. So in conclusion, there are a lot of reasons why we wanted to make concrete material applicable to help with climate change. And one of the reasons is because every tons of cement produced, it will generate about 1 ton of CO2 emitted into the atmosphere, because cement is produced in the current, so it needs to be heated, and that heating process generates CO2. And there is Norwegian studies showing that concrete within 100 years would naturally absorb the CO2 that it produced initially. However, to improve that process, we can make carbon concrete, which can actively reduce the CO2 into the air. Okay, so imagine if the amount of concrete we produce for building materials, if all of them can actively absorb CO2, then we are actually building an environment that is cleaner than ever. Okay, we can actually make a urban forest of equivalent of a natural forest that absorbs CO2 naturally. And then the electric and magnetic properties of concrete, as we demonstrate, has valuable applications both in the thermal sensing as well as the stress sensing and the wireless power transfer technology, that all of them would help with the energy efficiency by reducing energy loss, as well as improving on the energy transfers. And so concrete is a material that has a lot of potential in improving our energy infrastructure. and you just need to have more research done. That's all the materials that I have. If you have any questions, please feel free to communicate to me at schen12@uncc.edu. Thank you.
Thank you very much, sir. It was a nice talk and nice informative session.
Thank you, sir, for the knowledge which you have shared with us. This will help us immensely in our further development. Once again, thank you, sir. Proceeding further, I would like to invite the eminent speaker of our final keynote talk for this day on quantitative assessment of life cycle sustainability of civil infrastructure framework and case studies by Krishna R. Reddy garu. Dr. Krishna R. Reddy is university scholar, distinguished researcher, and professor of civil and environmental engineering. He is the director of Sustainable Engineering Research Laboratory and also the director of Geotechnical and Geoenvironmental Engineering Laboratory at the University of Illinois at Chicago. Dr. Krishna R. Reddy received his PhD in civil engineering from Illinois Institute of Technology, USA. Dr. Reddy had 25 years of research, teaching, and consulting experience within the broad fields of civil, geotechnical, materials, environmental, sustainable, and resilient engineering. His research expertise includes environmental remediation of soils, sediments, groundwater, and stormwater, soil and hazardous waste management, and landfill engineering, engineering applications of waste or recycled materials, life cycle assessment and sustainable or resilient engineering, and geotechnical engineering. He is also author of 246 journal papers, 21 edited books or conference proceedings, 22 book chapters, and 224 full conference papers. Professor Reddy has given over 200 invited presentations in the USA and 20 other countries. Professor Reddy has received several awards for excellence in research and teaching, including the ASCE Wesley W. Honor Award, ASTM Hochentler Award, UIC Distinguished Researcher Award, University of Illinois Scholar Award, and University of Illinois Award for Excellence in Teaching. Finally, I oblige my gratefulness and gratitude for accepting our invitation and request you to take over the session, sir.
Thank you so much. Good morning from here, but I know it's good evening there. So the time here in Chicago is 8 a.m. And I want to wish everyone happy holidays, happy festival, happy Dasara. So I cannot see the screen like what you are seeing. Hopefully my screen is fine and you can hear me well, right?
Yes, sir.
Okay. So first of all, I want to congratulate the conference organizers to organize this conference on a very pertinent topic: sustainable construction technologies and advancements in civil engineering. This is very much is needed in civil engineering field right now. So I'm going to present a methodology to assess the sustainability, and I'm going to show how that methodology can be applied through a case study. So before I get started, I want to thank Dr. Paula Girish Kumar, head of Department of Civil Engineering, for inviting me to participate in this conference. So very nice. And also, I was really excited to see the name of the university, and it is, meant for women. So I really appreciate college administration for starting this college to empower women, which is very much needed in current circumstances. And I want to, congratulate the organizing committee for putting together a very comprehensive technical program and very nice keynote presenters. I just heard part of the presentation by Professor Chen. It's very enlightening, carbon reducing concrete, that's very much needed. You can see that importance from my presentation also. And I also want to thank Professor D. Nagesh Kumar, IASC, who was instrumental in introducing me to Dr. Paula Girish Kumar. So I also want to thank all of you I know it's late in the evening and you have been attending the presentations from the morning. I'm sure you must be tired, but hopefully my presentation is not that boring. So in my presentation, as I mentioned, I'm going to show the methodology to quantify sustainability. A lot of people talk about sustainability, but we need to quantify and really see, whether you are achieving sustainability or not. So I developed a framework, and so I'm going to explain that one. Before that, I'm going to explain what is sustainability is, functional definition of sustainability, and triple bottom line and life cycle stages. These are the things you really need to know, if you want to know sustainability and how to quantify the sustainability. Triple bottom line indicators, metrics, and tools, and then integrated assessment. So, and then I'm going to demonstrate how this methodology can be used. I know the conference covers all topics in civil engineering, so I wanted to choose something that can benefit everyone. So the methodology is applicable in every field of civil engineering, but this case study, may be more focused on particular field of civil engineering. And just closing comments. So let me first talk about this quantitative sustainability assessment. Okay. So before that, let's think about what is the big problem that we are dealing with. We have been doing civil engineering projects for many, many years. And we do these projects based on code or regulatory requirements, right? If you are designing a concrete structure or steel structure or foundation, we always look for codal requirements, regulatory requirements. And we make sure that we do the technical analysis and design so that, the system that we design is safe. And we want to see that whatever we design is easy to construct and it costs less. And then it does not take too much time to construct, right? So those are all good things. But we don't consider these additional factors which are becoming extremely important these days. The first one is the sustainability. And the second one is the life cycle thinking. And the third one is resiliency. So if you can think about these things in addition to whatever we are doing conventionally, we can actually develop very innovative solutions that are not only effective, but also could be economical. So this brings down to what is sustainability, what is life cycle thinking, what is resiliency. So these are kind of new concepts that all civil engineering professionals, students, researchers, faculty, everybody should be aware of. Now, sustainability definition, I'm sure you have seen this definition. This is the definition that many presenters use, the development that meets the needs of the present without compromising the ability of future generations to meet their own needs, right? So this is the UN definition that we use. So this definition is very, simple, brief, but it's very powerful. So what it is saying is that, let's not do anything stupid that will compromise, current generation and maybe even the future generation. So that brings down to, why we need to worry about this one. I mean, we didn't talk about sustainability 10 years ago. Now everybody is talking about sustainability. Why we are talking about sustainability these days much more than before, right? So one of the main reasons why we are talking about sustainability these days is this global climate change that is due to greenhouse gas emissions. So the greenhouse gas emissions are, carbon dioxide, methane, a few other gases, but mainly carbon dioxide and methane. We are emitting so much of that, and then you have this global warming effect, and that is causing a lot of problems. You're having sea level rise, floods, droughts, wildfires, so many wild things are happening, and that is affecting current generation as well as future generation. So this is not a fiction, this CO2, methane, nitrous oxide, these are the greenhouse gases. You can see, they have been increasing at alarming rates recently. And as a result of that, the global temperatures are changing. So this, again, is not a fiction. These climate change impacts are happening. So greenhouse gases are being emitted into the atmosphere as a result of global warming. and it is leading to all kinds of these problems. And these problems are not uniform across the planet. In some places it's drought, some places a lot of snow, a lot of flooding in some areas, tornadoes, and a lot of places wildfires, air pollution, and so forth. So these are all being witnessed now. I mean, in India, we are hearing about this flooding much more than what we used to hear before, right? And before it used to be, it's going to rain heavily, and then it's go away, and we didn't have any problems. But these days we are seeing a lot of these problems in India. I just got some pictures showing that, and some places it's too dry too. So there's a lot of information about the potential impacts of climate change. And then what I did is just this week, last week, an agency called Climate Central came up with the predictions on the impacts of sea level rise. So then I thought about, Bhimavaram could be right next to the coastal area. So I said, what could be the impacts of this climate change or sea level rise on Bhimavaram? So this is the Climate Central. You can go there and look at any location on the planet. So what we are showing is, if we have 1.5 degree of global warming due to these greenhouse gases, what would be the areas that are going to be inundated? Professor Nagesh talked about it. How do you map it? But these kind of things are going to happen more if we have the global warming effects. And in a worst case, if you have a 3 degree centigrade global warming effect, then you're going to have much more area that's going to be inundated. So as you see here, the Bhimavaram is going to be in big trouble if you don't address the global warming issue. If I'm living in Bhimavaram, I really need to worry about it. So I just took a close-up view of that. You can see the Bhimavaram and other cities that are going to be totally underwater if this global warming is not addressed. So again, this is the more close-up view of it. So all of you who are in Bhimavaram, you have a reason to think about this issue and a reason to worry about future. So that's what makes it much more critical for especially you are vulnerable to these impacts in the future. So this could be happening, in the predictions are uncertain, but depending upon what we do now, if we don't do anything, obviously global warming is going to happen. We're going to have 1.5 and then eventually 3 degrees, and then we have to face all these problems. So you can see how important it is to address these climate change impacts. Now, in addition to climate change, we have another big issue. That issue is exploding population growth and consequent impacts. So the population is, increasing at alarming rate too. So if you look at 1970s, 1960s, you have 3.5 billion people. Now we have, close to 8 billion people, and it's expected to increase more. So what is the problem, right? If you have more people, you have more demand for everything, right? So then you're going to use a lot of these natural resources, and you're going to deplete those natural resources very quickly. And everyone throws away stuff. So you have increased waste generation, increased pollution, air pollution, water pollution, all kinds of things. And the damage to ecosystem, people are destroying the forests, green fields, building, all kinds of things. That's not good. Loss of biodiversity. Biodiversity is extremely critical. Some of the things are becoming, extinct. Urban sprawl. You probably have seen, the city where you live in. It used to be very small before. Now it's so big, and that causes a lot of issues. And the economic disparities. People who are poor, they are remaining poor, and people who are rich, they are becoming very rich. So the gap is, increasing tremendously. And the social injustice. People who don't have voice or power, they are being suppressed significantly. So these issues are becoming more and more. And as you see, not only climate change, this is the increased population. We cannot do much about it, but we need to think about creative ways to accommodate more people on this planet without causing these huge impacts. So that really, worries everyone. I mean, it's people who believe in these kind of issues or who address these issues, they are really perplexed in terms of what should be done, right? So, this is a huge concern. So people are working on it, just people are not giving up. People are working on addressing these issues and be sustainable into the future. So the sustainability projects are being done at different levels. So global level, like climate pacts, like a Paris Agreement, those kind of things are happening at a global level. Even national level, India is doing some of the, policies towards the sustainability. For example, energy, the Indian government is proposing a lot of renewable energy. And regional scale also you can do it. For example, if newer area, if you look at the whole watershed, what can be addressed, what can be done, or business or industrial scale. For example, in your college, what kind of things that you can do, that you can think about that one. And lastly, this is the thing that it can be done by every engineer, like civil engineer. As a civil engineer, no matter what your specialization is, we are going to use the materials, we're going to design certain things, products and systems. So why not think about sustainability in things that we do on a day-to-day basis? It doesn't matter if you are in transportation, structures, geotech, environmental, whatever it is. In all of these things, we have to look at through the lens of sustainability that we were not trained to do that one in the past. So if I want to think about sustainability, what should I do? So the definition that you saw, the broad definition, it's very good. But in terms of doing something, that's not really useful. So the functional definition given by American Society of Civil Engineering is really a good definition. So you can find this definition online. But one of the key terms in this definition is the triple bottom line. So what it says is environmental, economic, and social aspects should be considered, and make sure that they are not compromised. So that will ensure the quality of life indefinitely. So that saves people now and into the future. So this concept of triple bottom line can be applied at different scales, even at project scale. So this provides a functional definition. Basically, we can take this definition and do something to make the difference for sustainability. So you must have seen this Venn diagram. Whenever people talk about sustainability, they show this diagram. So in addition to all the things that we do now, we need to subject our designs to these considerations. What are the broader environmental impacts? What are the broader economic impacts? What are the social impacts? So we really need to think about indicators, metrics, and tools for these triple bottom line aspects, and then see if our design is sustainable or not, right? So when you talk about environmental sustainability, here we have three things, environmental sustainability, that's mostly talked about, but there are, economic sustainability and social sustainability. So when you talk about environmental sustainability, you're talking about how much energy, carbon footprint, smog, acidification. These are all the broader environmental impacts that you want to look at it. These are indicators, and then you should be able to quantify these numbers for any given project, and you need to have tools to calculate these things. So if you have these tools, you can look at how environmentally sustainable is your design. One of the common technique that is used for environmental sustainability is called life cycle assessment, LCA. So it's a standardized ISO 14040 method. So you have inputs, and you look at all the life cycle stages. You have outputs, then those outputs are basically your environmental impacts. So there is a standard 4 phases of a LCA. You need to define the goal and scope, and life cycle inventory, life cycle impact assessment, and then the interpretation. So we teach this methodology in our courses, and we make our students to do some projects based on this. On the economic sustainability, direct costs. I mean, a lot of our civil engineering students learn, how to do the cost estimate. That's the only one part of it. But we need to learn about these other things: indirect costs, direct benefits, indirect benefits. Monetizing those aspects in our economic analysis. And there are some tools developed for this one, and more tools are being developed as we speak. So, this is the part that, civil engineers are not very comfortable with. So we need to work with the economists or we need to use the tools that are being specifically developed for civil engineering applications. The other one is the social sustainability. So this is the one, basically whatever we do, how the community is going to be affected, how the people are going to be affected. Civil engineers are very bad about, addressing these issues. We just think about something, design it, and then we think we implement it, and the people around that area will like it and use it. But that's not the case. You really need to, bring people on board and then make sure that they are part of your team, and they can, provide the comments and suggestions on what can be done so that their lives, can be improved. So there are many factors that you can think about how your project could help people, right? So these are some of the indicators. And then how do you quantify these? That's a huge, problem. But there are no tools, but some tools are being developed. For example, I developed a tool called ScTACE recently, and kind of a rating tool, but it's better than nothing. But these tools are being developed more on these things. So what we have to think about is, when you talk about sustainability, we need to think about triple bottom line. So environmental aspects, these are all the indicators, and economic aspects, these are all the indicators. Social aspects, these are all the indicators. I hope you can see my cursor. And then once you have those indicators, we should have tools to calculate those metrics, okay? And then once you have the metrics, you should be able to decide whether your design is sustainable or not. The other thing that civil engineers don't really understand is the life cycle thinking. So a lot of times, we think that materials are going to magically appear to the site, and we construct it, and then we use it. That's what civil engineers do it. But actually, we need to think about life cycle of a project. So you need to look at going back to mining, what kind of resources are mined and how the materials are manufactured, for example, cement, steel, whatever it is, and the transportation, what kind of things are involved during the construction, during the maintenance, and also end of life. It could be 50 years, 100 years, whatever the design life is. At the end of the design life, what are you going to do with the materials that you're going to demolish, right? That needs to be thought about it right up front, so that most of the materials that you use could be recyclable. And if you don't think about that one, most of the things have to be dumped somewhere. So that's not good. So we need to think about these life cycle stages. These are called life cycle stages, and you want to consider the impacts at each life cycle stage, and you add them together. So this is very important. So that's what I did. And these are all the life cycle stages. You can see the first, and then you apply the triple bottom line aspects and combine all those aspects. Now the question is, you have these multiple indicators with metrics, then sometimes they're conflicting. You're not going to see, if you have two options, you're not going to see one option consistently having better results than the other one. Or even if you have one option, how do I calculate the sustainability index? Can I combine all these factors to come up with a sustainability index? So that's where we developed this tool called Qualix. And I don't have time to go over this one in detail, but basically in this one, we look at different alternatives, and then we look at the requirements, criteria, indicators, and we assign the weights if it is needed, and calculate each indicator and calculate the value function, and then determine the sustainability index. And then one of the important things is you have so many indicators. You may consider all of them equal, or sometimes some of them are more important than other ones. So we use this analytical hierarchy process to come up with the weightages. And finally, you have all the indicators: environmental, economic, social, and the criteria: environmental, economic, social, and requirements. And then combining all these things, we can calculate the sustainability index. So we're calling this one as a framework, and calling it as a Qualix. And if you want more information, I suggest you to look at this reference and then get more information about it. So if you need that reference, just send me email. I will be happy to mail it to you. Just I want to show you, this framework can be applied to any project that you are working with, transportation, environmental, structures. But I want to show you for one example. So this is the project where we needed to construct a vertical barrier here to contain the contamination that is coming from the dump site. So a lot of contamination, toxic chemicals are being released. So you don't want that one to be spreading into the environment. So you need to have a vertical barrier that does not allow this contamination to spread out. So these vertical barriers, there are different barriers are possible. One of them is called a slurry trench soil bentonite cutoff wall. So here you basically dig a trench under slurry, and then you backfill with soil that is mixed with the slurry. So that's called backfill. So basically you're taking out the existing soil and then backfilling with a low permeable soil. So that becomes a low permeable vertical barrier. That's one way. There could be other way. This is they excavate it, and instead of backfilling with the soil, they backfill with a mix of water, bentonite, and blast furnace slag. And then what happens is once you put it in there, it will harden in place. So you don't have to backfill with a soil that is amended with a bentonite like you have done in the first method. So this is another option. This is also used commonly. And then a third option is soil mixed walls. So basically, you use some of the cementitious agent, like most of the times Portland cement, and you mix it into the ground, and then that becomes a barrier. This is also can be used for constructing that barrier. The other way is the sheet pile wall. So you drive these sheet piles into the ground, and you are making the barrier, vertical barrier. So these are the four cases that we have. So you have soil bentonite slurry trench as SB, and this cement-based SC, and soil mixed wall SM, and sheet pile wall SB. Now the question, all these three can serve the function, right? So which method is sustainable? So we can argue about it, but we will never reach into the consensus. So that's why you need to have a quantitative framework to calculate the sustainability metrics, and then that will help you to answer the question, and people will not have any argument about it. So this case study involved constructing a small barrier, vertical barrier. It's a soil bentonite barrier, but we are comparing what would happen if you use a different types of barrier. And this is the soil profile, and basically you have here, say, silty sands, and that's where the barrier system is going to go, and it keyed into the low permeable soil below it. So this is the, again, the Qualix framework. As I said, there are different steps that are involved in this one. And then you apply this framework to all these different barrier systems, SB, CB, SM, SP. So now what we're trying to figure out is which one is more sustainable, which one we should recommend to be used, right? So for each case, you need to look at, what it involves in doing the construction. Here are the site overhead, mobilization, site setup, mixing slurry, excavation, backfilling. So what are the different steps that are involved in construction of these barriers? Some of the steps are applicable only for particular types of barriers. And then, for each of these steps, what kind of things you need, the equipment, materials that you need. And you input this information to life cycle assessment. You can use computer software such as CIMA Pro, and then you can get these environmental impacts. So these are the environmental impacts you can look at it. So the results will look like this. So these are kind of broader environmental impacts. And for these four options that we have, so let's look at the global warming. This global warming is basically carbon footprint or greenhouse gases that are causing the climate change. So this is the most important one. People look at it, and you can look at this SB is as the lowest carbon footprint, and on the other hand, SP as the highest carbon footprint. If I'm in Bhimavaram, this global warming is my big concern because I don't want sea level to rise as a result of these greenhouse gases. So obviously, my choice just based on this would be SB. But you need to look at these other environmental impacts also. So you can see, consistently this SP has a really worse impacts, and SB seems to be consistently a better choice for this one. So here we are quantifying these impacts, right? So if I didn't quantify it, then you can, argue about it. Also, this depends upon the transport distances a lot. So if I, want to look at the transport distances, let's say, transport distance is not a big issue. Like all the materials are available within 10 miles distance. Even, based on that assumption, you can see the same conclusions here. So now we need to look at the economic aspects. That's the environmental aspects. And then you look at the economic aspects. In the economic aspects, you have a direct cost, and then you have these externality costs, like monetize the environmental costs and the total costs. And there could be a lot of other things that could be included here, but we just use the social cost of carbon as monetize the environmental cost. And as you see here, SB as the lowest cost, and compared to SB that has the highest cost. Now the other assessment is the social sustainability, right? So you need to really look at how this wall is going to affect the people. So there's a methodology, as I mentioned, social sustainability evaluation matrix that I developed some years ago. And basically what it involves is looking at the functional indicators, and then social individual, how people are going to be affected, how the community is going to be affected, how the socio-economic situation is going to be affected, how the community level environmental conditions are going to be affected. So these indicators you need to define based on the project, based on the situation, and then you do a survey of the stakeholders, people who are working, experts, policymakers and other things. So you send a survey and then get the responses, and then see those based on those responses what people prefer, right? So you can analyze that data, based on this. So you are taking into account of the impacts of your project on the individuals living in that area and community that is living in that area, and how that the community and economic conditions are going to affect how the environmental conditions are going to be affected. So these are the things which are very important. Ultimately, civil engineering is a profession serving the people, and you need to consider how the people are being served by your project. So again, this the methodology I showed you before, and we use all those environmental indicators, economic indicators, social indicators, and we apply these weighing factors if it is needed, and then ultimately we come up with a sustainability index. So once we calculate the sustainability index, overall sustainability index, considering all the triple bottom line aspects, so the higher the sustainability index, better it is. So obviously you can see, in this case is, SP as the lowest sustainability and SB as the highest sustainability. You can look at the environmental sustainability contribution, economic sustainability contribution, and social sustainability contribution. So, SP is very bad. The sheet pile walls are very bad from environmental point of view, economic point of view, but people like, if you don't have anything, that's worse, right? People want something. So always, doesn't matter, which type you want to use. People like to have a vertical barrier rather than not having one. So based on this analysis, so this is kind of the final result you get from the framework. Here I have 4 options, and based on my quantitative framework, I can definitely say that SB system is going to be more sustainable. So just this kind of a conclusion you can get it. But one thing I want to warn you is that this conclusion may not be valid in general. So you really have to look at site-specific conditions. So the sustainability assessments have to be done for every case, that every project that you're dealing with. So that's the caution that I am making it. So if you want to have more information about this this example, so this is the paper that you should take a look at it. And I will be happy to email this one to you if you want, or you can go to my website. You can find this one. So I want to thank my collaborators, working who helped me on this project. So this is my last slide. I want to just mention that we should be thinking about life cycle sustainability assessment in our design work, no matter which one we are doing in our civil engineering. That provides the rational basis to assess, which one is more sustainable. And then LCA, life cycle assessment, we are teaching that one in our undergraduate and graduate level classes. That is a good tool for assessing the environmental sustainability. But there could be more done on life cycle economic and social sustainability aspects. But whatever we can do it, we should do that one. So currently, I can say, sustainable design is not required by the codes or regulations, but thinking ahead about implications of not addressing the sustainability, it's a a moral irresponsibility if we don't do that one. So we must consider sustainable design in every project that we do. And a lot of thoughts about sustainability, right? This day was about sustainability. But let's not talk about too much, but let's implement it and make the difference in the field. So sustainable engineering is extremely important. So I want to mention that if you guys are interested in learning more about sustainable engineering, so you can look at this as this is the textbook I wrote a couple of years ago, and I use this book to teach a course on sustainable engineering. So I highly recommend you to have an elective course at undergraduate level, and maybe even required course at the graduate level on sustainable engineering that talks about all these concepts. And I want to take this opportunity to mention that I organized a weekly webinar series on broad topic of geo-environment engineering, polluted land, waste management, sustainability, and resiliency. It's on every Friday, 7:30 p.m. India time, 9 a.m. Chicago time. And I highly recommend you to go to this website that I'm showing here. And they are free. You can, attend any one that you are interested in. There are a wide range of topics and expert speakers. So, if you want to be connected on what's going on in the waste and environmental issues, sustainability and resiliency, this is a great way to get in touch. So even if you are shy to ask questions, or if you have questions later on, feel free to contact me by my email. I'm also on Twitter, Facebook, LinkedIn. There are a lot of Krishna Reddys, but I have a middle initial R that distinguishes from me and from other people. So, or you can go to my websites, lab websites, and you can find more information about all my research projects. I do a lot of other types of research too, but sustainability and resiliency is one of my favorite topics that I'm working on these days. So you can find more information about these, on my websites. So that's the end of my presentation. I will be happy to take any questions that you have, or whatever is next, Dr. Paula. Thank you so much.
Nice meeting you first. And this is second time I'm attending your series, sir, because you have done one program with our sister institute, BV Raju Institute of Technology in Arsapur.
Yeah, right.
With the head of the department, Sri Devi, if you could remember.
Yeah, exactly. Yeah. That's right. Yeah. Thanks for hooking me up with this program. So there's a lot of interesting things that can be done in the sustainability world. As I mentioned, we are always interested in doing specialized things, right? We teach our students a lot of design and other things, but I think if we need to teach them about sustainability, it's a high time for us to teach them.
There's someone requesting to suggest some topics on sustainable development for doing research.
Yeah, there are a lot of things. As I mentioned, you can just anything you do it. I mean, like sustainability is such a broad topic. Whatever you're doing, let's say you're working on some project right now, then ask this question: is it sustainable? How can I check whether it is sustainable, right? And you can do the sustainability assessment in any project that you're working on. So a lot of times people do the projects without thinking about sustainability. So these days, I'm glad that somebody asked that question, because you want to think about sustainability upfront, before you take that project. And there's a lot of scope for projects like Professor Chen has mentioned. If you are in structures area, carbon sequestering concrete, but a concrete that does not use that much of the cement. That's cement is a huge problem. So if you can find alternative mixtures for concrete, that's good topic. And there are many topics that you can work on, the environmental side, transportation side, infrastructure side. I would highly recommend you to look at that book that I mentioned, and there at the end, last 3 chapters gives you examples of sustainability projects in the materials engineering, environmental engineering, infrastructure engineering. So you will probably get more ideas from there. So happy to see so many students have joined. So I hope they are listening to me, and I will be very happy to help any way that can be helpful to them. So students can contact me by email or can ask me questions, whatever it is. So now that we connected virtually, so feel free to send an email.
I request participants, if at all you have any queries, and please do interact in the next couple of minutes so that we can conclude this session.
A pleasant good morning, sir. I am Srisa Krishna of 3rd Civil. Hello, sir.
Yep.
Yes, sir. I have one question, sir. How can the triple bottom line be improved with sustainability, sir?
No, the triple bottom line is the sustainability. So the definition of sustainability, as I said, sustainability definition, the broad definition, there's a general definition is there, but a triple bottom line is kind of a functional definition of sustainability. You get it? So if
Yes,
I can, so if you environmental aspects, economic aspects, and social aspects, if you consider all of these things, then you are basically trying to achieve the goals of the sustainability. So remember, what is sustainability is all about, reducing the climate impacts, right? So reducing the greenhouse gases. So
Yes,
the greenhouse gases is one of the indicators in environmental sustainability. But not only that, you with the people, with so many people, you have air pollution and other things. You want to consider those other aspects also. So the consideration of the triple bottom line and sustainability are synonyms. So they are almost like one is the general definition, other one is the functional definition.
yes.
So
Sir.
I like to think about if you want to do something towards sustainability, so just think about triple bottom line as the way to do things.
Yes, sir. Thank you, sir.
You're welcome. Anyone else? I know a lot of people are there, the shy, I think, right?
Hello, sir.
Yep. Go ahead.
Sir, good morning, sir. First of all, your lecture was very inspiring, sir. Like the topic you have covered was like something which is very needed at this point of time. So my question is that, sir, I have been working on parallel projects in my undergraduation, sir. I have worked on rainwater harvesting in the area of water resources and also parallelly worked on pervious pavement, sir, which comes under transportation, pavement technology. So my question is that we generally look for sustainability in both the projects. But the thing is that though we have both the projects from a longer time, but those are not very used, like they are not implemented on a wide range. Though we take sustainability as the major aspect, they are not concentrated more, sir. So can you just give some insights on this, sir?
So yeah, that's very much needed. So as you said, you're working on a very interesting projects. Water harvesting is very important. You know that water is a precious material, resource that you want to think about it, and so that's a very nice project. And pervious pavement, not only transportation projects, it could be like you consider as an environmental project too, because and water resources projects too. So the pervious pavements basically infiltrating the water into the ground, so you're avoiding the flooding. And sometimes this pervious pavement can take out the contamination out, so you're recharging the aquifer. So there are a lot of benefits, just not about transportation. You can realize a lot of environmental water resources benefits in that one. So obviously, they are sustainable compared to conventional methods. Again, what you are doing in each of these, you can look at the triple bottom line and see if there are improvements that you can make. So then to answer your question, So the sustainability is still not embraced very well. Okay, because a lot of people need to be educated. You have politicians or policymakers or some of the senior professionals in the field. They're not ready to listen. They want to do the same way that they have been doing for many years. But as I mentioned, the future is looking bleak. When you get into the troubles, then you have no other option than doing it. And a lot of people are doing that one. Sustainability is like a big, broader concept, and people are a little bit hesitant to do it. But climate impacts, right? And they're happening, and people are getting, inundated with, this flood water and everything. And they are saying, oh, let's do something, otherwise my house is going to be flooded. So they are ready to take up some projects for addressing the climate impacts. And now the question is, those projects are to address the climate impacts, but we need to do them sustainable manner, right? So, for example, Bhimavaram, I showed you, I don't know how many of participants are living in Bhimavaram or surrounding area. The picture that I showed you, you show it to your parents, and show it to other people you're dealing with. Say that Bhimavaram is going to be in trouble in the future if the sea level is going to rise. So what should we do? Should we have these sea walls, like big high sea walls to protect Bhimavaram? Or what can we do? There may be some way to relocate and have a buffer zone, have some kind of a floodable park, some kind of a nature-based solutions to address the problem. So the problem is the education, I think, and it's time to make everyone aware of the sustainability issues and climate impact issues. And they should think about this one way before they get into actual trouble. And that time, you don't have much time to really, think about all the possible solutions and act, properly. So the planning ahead, is very important. And then planning ahead, let's say, oh, how do I know if 1.5 degrees is going to happen or 3 degrees are going to happen? So there's a lot of uncertainty, right? So that's why, in our engineering concept, we are thinking about designing flexible systems. The flexible systems that can be modified in the future if it is needed. Right now, we don't do that one. Let's say you have a flood wall. Okay, we predict this so much surge, and we design for that one. We know that value is not correct. It could increase. We don't know how much is going to increase. So can you make that flood wall taller if needed? So that flexible design concepts, we need to think about it, because you don't want to spend a lot of money building a very high wall now, not knowing whether that thing is going to happen or not. But if it is going to happen, can I modify my design to accommodate that? So it's kind of a nice question. But I think, a lot of young people that I know, there are a lot of youth students, should think about the sustainability, and, maybe towards the later part of your life, you're going to, feel these effects, and definitely your kids are going to be affected and your grandkids are going to be affected. So, this generation is very, some of the people are very reluctant to, act until, they get into trouble. So that's a good question. I hope I answered the question. So it took a long time to explain, but hope is that okay to answer?
Yes, sir. It's perfectly clear, sir. Thank you, sir.
Sure, no problem. Anyone else?
Well, sir, thank you very much, sir. Yeah. Actually, we came to know that this the impact of this in the Bhimavaram, because we are located in Bhimavaram, and definitely we will try to do something for this society and for this location, as you mentioned in the slides. And also, you have nicely covered the sustainable engineering and how sustainability is so important for today's generation and all in future. So definitely, I try to be in touch with you and try to do some project works and helping mainly this Bhimavaram town. It's a very important thing that you have quoted. Even you could see in the map also. I was not knowing this much. Today I came to know something we have to do for this in terms of this. And I really thankful to you for your presence and support and encouragement. And I wish this continues further. further in future also. And I thank Professor Nagesh Kumar sir for giving me opportunity to meet you this platform and have an interaction. And hopefully we'll have a couple of interactions in future also.
Sure.
My
So
students will be benefited if you could give a lot of insights maybe in future. My students are really more enthusiastic, and more they're having good perception towards research, because we at the undergraduate students, they are writing good articles, and also we got a good citations for their papers also. So such kind of students are having in the institute. So I really request you to extend your support to encourage our students in terms of research and do some contribution to the society, sir.
Yeah, sure. I would be happy to do that one. And if you want to have some informal, discussion sessions, I will be happy to, now with Zoom and all this, Teams and other things, it's so easy to do it. So I would be happy to have some informal discussions and, help the students as much as I can. So the students, should be, very proactive in doing things, and there are a lot of things that can be done. Yeah, thank you so much again for everyone, and and I wish you all happy Dasara, and enjoy, and then also be safe with the current situation. Okay.
Okay, sir. All right, sir. Thank you, sir.
All right. Bye everyone.
Thank you, sir, for sharing a valuable information with us. Your talk has worked as a starting point to resolve important issues in this area, and this inspired many of us to take individual initiative. So, our first day of Second International Conference on Sustainable Construction Technologies and Advancements in Civil Engineering has come to an end. Sincere thanks to all the keynote speakers and presenters for your wonderful presentations. Furthermore, let's have a special recognition to all the listeners who remained patient throughout the session and encouraged the morale of the speakers by their gusto and enthusiasm. Thank you so much for being our pillars of support. We are expecting the same number of audience for tomorrow's sessions that going to be held at 9 a.m. I request everyone to join through the same link and make it as success as today. Thank you all. Have a great day.
Thank you, sir. Have a good day, sir. Thank you.
Yeah, thank you. Bye.
So we are ending the session, and hopefully, as said, we will meet tomorrow sharp at 9 a.m. IST. Thank you once again. Thank you, everyone.